Good day. Welcome, everyone. We're super pleased that you've joined us. We've got a great topic, cloud security. I think that's on the mind of everyone. We're always thinking about security, but especially with everything that we're doing in the cloud these days. My name is Mitch Ashley. I'm going to serve as your host and moderator. This is a TechStrong Learning panel sponsored by TechStrong. And if you're not familiar with our security site, it's Security Boulevard. We have a lot of webinars on security there, as you might imagine. So a little bit of housekeeping here before we get started. I'll introduce our panel. This is going to be all discussion. So no slides, death by slides. We're not going to be doing that. So it's all conversation. We have some topics teed up. But a few housekeeping items. One is we are recording this. So feel free to jot down something interesting. Somebody mentions the site or whatever. But we have a recording of it. So everyone will get an email with a link to that recording, and you can share it with friends or listen again, whatever you'd like. Also, we have a gift card drawing at the end that we'll be doing. So we'll announce who those are. Last, but I think actually most important, is the platform that we're on is actually kind of really nice for interactive conversation, not just us talking to each other and talking to you, but you can join in the conversation. So there's a really nice chat feature. There's a Q&A tab. Please use that because we are going to be talking on chat with you and each other and chiming in, and you can change the flow of the conversation. You might introduce a question or a topic or a comment or whatever, I jump on it, or somebody says, hey, Frank over in the chat asked this. This is a really great question. So please participate. I think you'll get even more out of this conversation, maybe directed to some topics that you'd like to talk about yourself. So let's get to our topic, cloud security. And I'm super pleased to introduce this I'll say illustrious panel, guys. I'll give you that. Okay. So let's start this way. I'm going to ask you each to do an introduction of yourself and just tell us a little bit about you. Tell us a little about the company that you work for. Justin, you want to go first, please?
Sure thing. So my name is Justin McCarthy. I'm the co-founder and CTO of StrongDM. And so what we are all about is the access part of security. So for every member of your technical staff, your engineers, your data scientists, anyone who needs access to sort of the big systems, the servers, the Kubernetes clusters, if they need direct access, then you need some sort of approach to grant them access. So that's what we are all about. We're about formalizing that and auditing that for you.
Identity and access, right? Two fundamentals of security. Philippe, how would you like to introduce yourself, please?
Yeah, I'm the CEO and co-founder of CrowdSec, which is an IPS, an open source IPS, which is participative. We are some sort of ways of cybersecurity. So not only we block the attacks that your system are getting, but we also broadcast the IP that has been aggressive toward you to all other members of the network. Meaning, we create some kind of global shell to protect each other and have each other's back, and it's for free. It's CrowdSec.
Very cool. Taylor, jump in next.
Yeah, Taylor Smith. I'm a senior product marketing manager for Bridgecrew by Prisma Cloud. And our primary product is we cover cloud infrastructure security all the way from build all the way to runtime. So we do infrastructure as code security with our popular open source tool called Chekhov. And then we do that all the way through to runtime. So we have some CSPM capabilities. So check it out.
Okay, excellent. And Yasser, if you kind of bring up the rear here.
Sure. Thank you. So my name is Yasser Fuentes, and I'm a technical product manager for Bitdefender. So my area of specialization or portfolio is cloud workload security. However, as Bitdefender, we cover anywhere from consumer to cloud security to B2B2B, basically OEM. That's a way in which we started in the B2B market. And also we provide security for MSPs as well.
Excellent. Very cool. All great companies and great representatives of your companies. Now, we're not going to be talking about products. So this is not a product pitch. This is an expert conversation, kind of sharing our knowledge and experiences and questions we may have. So we're talking about cloud security.
Mitch, maybe I'll give a brief intro as well.
I'm sorry. Curtis, I skipped over you. My bad. I'm sorry. Thank you for stopping me. Please jump in.
I won't take it personally, but
no, it was not a slide, trust me.
Of course. So Curtis Barker, the VP of Product Strategy and Field CTO for Resilient. Resilient is a DevSecOps automation capability, and what we're famous for is reducing our customers' patch burden by up to and more than, in many cases, 70%. And if anyone's been involved in patching vulnerabilities before, that's huge from an organizational standpoint and in terms of protecting your attack surface. And that's full stack across the host infrastructure that your applications are built on, and across your application proprietary and open source code, and then helping to be able to provide that level of automation and highlight the risk from a security standpoint across your service stack, from your CI all the way through to your production environment.
Fantastic.
So
Super
great to be with
important part
everyone
of what
today.
we do. Yeah. Thanks for being here. So let's start. I had to go kind of to the fundamentals, but maybe we can get a working definition of what we mean by cloud security. Security is so broad, right? We're talking about compliance at one end and identity and everything in between. Curtis, if you would do us the favor, maybe start with helping us put a little bit of meat on the bone of what we want to define cloud security to be. It doesn't have to be the accurate one. It's just what we're going to use today.
Yeah, absolutely. I've been working in this space for a long time, and it's been a real revolution when you think about just how services are built and the amount of services that we now use as a result of the emergence of cloud. And some of the big differences and changes as it relates to security risk for cloud compared to a traditional IT infrastructure. Of course, first one being responsibility. The responsibility model for working in the cloud is very different. You still own your data, but in terms of the infrastructure and the responsibility for securing that infrastructure and some of the managed services that are offered in the cloud, that's the responsibility of the service provider. So if you're in Azure, Azure is responsible for the infrastructure that they provide you to run your services. And sometimes you may entrust them and purchase managed services off them. And in those cases, they're responsible for some of those managed services also. So a good example would be kind of managed container services, where they will actually provide the host and container infrastructure and kind of manage the orchestration around them as well. They are responsible for that, including keeping the images, keeping the host up to date, so that there's not a significant vulnerability buildup. Another big kind of difference is data, of course, is no longer on premise. It's distributed outside of your environment. So kind of managing who has access to that data and how that data communicates outbound is a significant change. And one of the things that a lot of organizations have been focused on there is developing an access control plan as part of that. What are the permissions, what data has access outbound, who has access to that data inbound, and that's really important because you've got a single control plane for your accounts now that may involve many hundreds of services, as opposed to having it on premise and being able to kind of control the control plane of access is very different, and it's not kind of a singular control plane. Of course, infrastructure as a service, we talked about managed services. The infrastructure now, everything is a service. So how do you identify risk for services that you're no longer responsible for and that someone is managing on your behalf? At the end of the day, your customers are going to be looking at the organization that they purchase services on as a custodian of managing risk. So it's no good, even though there's a responsibility model that you need to be aware of, you're still the ultimate custodian of risk when it comes to your end customer, which means it's very, kind of, you've got to be very mindful, and it's incumbent on you as a service provider to your customers to then be able to identify the risk of any managed service that you provide you get provided from a cloud service provider. The last one I'd say is innovation. The type of innovation you get with cloud services is significant. We've seen things like serverless, container orchestration, all of these kind of different, not just security services, but build services be provided by these cloud service providers, that has been at a much greater velocity than you would have had from the innovation of kind of on-prem traditional IT. So from that point of view, that's provided a lot of speed, agility, and change that has led to a lot of automation and innovation. So, I'll end there on a positive. All of that, of course, comes with risk, but we've seen great innovation as a result of cloud and cloud services.
Well, you did both a great job of helping us understand a little bit. And I'll, Justin, have you comment, but you also proved me right. It's a big topic. It's a big space. Justin, you want to jump in and add?
I just want to, my working definition of cloud security is just to delete the word cloud. And so I would say that everything that occurred back when what we needed to secure was roughly in racks. Still, there is a correspondence to clouds. So the way I test it intellectually is, I imagine like back when we could walk up to a rack and understand the top of rack switch and understand where the firewall is and understand where the core router is. That understanding leads to it's a training opportunity for everyone. It creates a shared mental model, but with that shared mental model, you can see the difference between a well cable managed rack and a poorly cable managed rack, and a well labeled set of cables and a poorly labeled set of cables. And so when I think of cloud, I think of cables that just need a little bit more cable management, and they're really thin, and they're very flexible and very long. And
well, they
so
only go as far as the diagram, right?
So you just need to have more attention to your labels and your design. But otherwise, there's a correspondence between essentially everything that we did before and after cloud. So that's my working definition. Cloud security is security.
Mitch, I was thinking, listening to the panelists, that there's something that strikes me from, just to defocus a bit the conversation. With the cloud, we are automating so many things, so many workloads, and the DevOps community is doing a great job here and helping the global growth of the ecosystem. But we are just catching up with the cyber criminals here, because they have been automating their attacks forever, right? So what we are doing now as the good guys, they are doing it on the other side of the fence forever. So the only difference is when you get the loot, it's way bigger, because as Curtis has highlighted, if you compromise one thing, you usually get access to hundreds of servers, workloads, or cubes, or whatever is behind, where usually you would breach one point or one part, So it's a bigger loot, it's a more automated loot, and we are catching up with the cyber criminal industry by industrializing ourselves.
Yeah, so and I have an only slightly biased opinion here, where I think one of the things that shifted, and it moved to the on-prem, so that mental model that Justin mentioned is still apt, but infrastructure as code kind of came with the advent of cloud, and then it moved to the on-prem. So you can still manage your firewalls with infrastructure as code, but that kind of came with the cloud. So now you can shift security left and do a lot of your cloud infrastructure earlier. The only thing I think that is slightly different in the cloud is the mental model that we had before, where you might control where VMs are placed, has kind of gone out. So now before you might have to worry more about firewall rules between external services, you don't have to necessarily worry as much about a breach happening and virtual machine escape from one virtual machine to another, because AWS or Azure has spread your EC2 instances or your VMs across multiple servers that you don't control.
Yeah, from my perspective, I would second Curtis and Justin. So in the end, it's just security, right? It's information security translated to the cloud, right? Adapted to the services that we can procure and get from the cloud. It's the same, I would say, comparison when people talk about cybersecurity and information security, right? At the end of the day, is security, right? It's just in a different context and a totally different environment.
Does the fact that I know when we were all kind of first moving things to the cloud, one of the big issues, well, it's not my data center. This is someone else's. Do I trust it? So sort of the physical aspect of that we don't have as consumers of the cloud. Of course, the cloud itself does. Is that still important? We just letting the cloud providers take care of that? We don't worry about the physical part of it, or is that still an issue? We need things on-prem for data and policy and compliance reasons.
Funny enough, jumping into a data center and going into a room that would not be yours is not so complicated. Now, if you try to go into Amazon data centers, I'm pretty sure you get shot on sight.
Yeah, you don't have credentials, right, to get in there.
Yeah, if you don't have the credentials.
Yep, absolutely. Is there anything that's substantially different? You think it's so? Let me pose the question this way. I remember going to the first AWS reInvent in, what was it, 2011 or 12, whatever it was. And, at that time, my thinking was, okay, I've used it since 2009. Seems like a sort of a different version of a VMware environment. Everything's virtual. And then when I started hearing talks about how people upgraded their applications because you had elastic compute resources, you didn't have to do a rolling upgrade that's limited by your own physical infrastructure. That was like, okay, so we can do some things differently. Are there things we need to think about doing differently in the cloud when it comes to security?
I'll say this. The thing that's most different to me is that theoretically there's more flexibility, right? So there was a forcing function previously where anyone with a good idea couldn't just launch or deploy because you had to. There were physical gatekeeper. There was a physical gatekeeping process, right? You can have a cool idea, but you're not going to be able to deploy it unless you get it into that cluster of servers, which was physically guarded. So I would say being very, very conscious about when you allow yourselves as an organization to use that flexibility. I think is you have to have a discipline, and you have to make very explicit choices about who and when and how you're going to create segmentation between things that are sandboxes and development environments and your production environment, and what your change control is going to be. So there's the missing guardrails and forcing functions that you had in more physical environments.
Very true. Everyone with a browser and a credit card can be in the cloud, right?
Yeah, and I think, Mitch, that's led to one of the things Taylor was talking about, this cultural shift left, right? Where you've got developers now not needing to ask for the keys to the castle from someone that controls them to, wait for a resource to become available to start testing a application. They can go and spin up a test environment really quickly and start using that test environment and doing, A/B testing, some kind of, it could be quality assurance, functionality testing, and that may or may not be approved. It may not be within the realm of visibility by the security team because it's not deemed something that's production ready yet, but it may still be accessible and attackable, and you're still representing your organization. So it still presents a lot of risk. In fact, an old colleague of mine used to use the analogy of AWS environments being like bunny farms, right? They just first you've got 5, and then before you know it, you've got 30 of these things without even knowing. They just kind of breed throughout the environment. And then the risk potential of that, the risk implications are very significant organizationally.
If every other PHP author can go live and, commit something and you reuse a credential that he used somewhere else, you're actually jeopardizing way more than just a pre-production environment. So no, it can actually be also a big disaster. If they use it within constraints with a clear regulation, that's fine. But if you start to be, doing it in your back, it's terrible.
So let me throw this out, playing on this idea of theoretical flexibility. One of the things that I've kind of adopted for myself is everything is immutable, changeable in theory, and a lot of it does happen. So you almost kind of live in this world where the state of our entire architecture, applications, infrastructure code, all of that is never actually in one solid state. It's kind of almost like quantum physics as opposed to, Newtonian physics. It's changing all the time. Seems like for us as security professionals, as you all as technology providers, that the rate of change and the things we have to deal with may be the same things, but the frequency, quantity, it's not 24 by 7. It's, how many hours can we fit in a day? 26 by 7. It seems like we're living in a constantly fluid world, and that might cause us to rethink security a little bit. Agree, disagree? You can totally disagree if you think that's a foolish notion.
So Mitch, I would offer one governor on that sort of utilizing the flexibility. One governor that you do have is that human function of the SOC, right? So the human function of responding to alerts. Okay, even if you have a great amount of leverage in your tooling, so that the alerts are few, right? If you have a human on the other end, and you actually require of those humans to be able to understand and explain every alert, okay, then that can create a virtuous. You can structure that so it's a virtuous feedback loop to kind of prove that anything that could happen in the day-to-day is understandable, right? So if you have an excess of creativity, you're going to have a decrease in understanding at your alert interpretation and action time. Right. Mm-hmm. And so obviously there's a lot of judgment calls in there. But I would say that's one governor, that's one loop of, does everybody who's responding to alerts understand what they mean? Right. And if the answer is 80% yes, and it stays 80% yes, then you're probably okay.
Yep. And even if we drive efforts in terms of like, making sure that security is baked in, that our developers understand a little bit better about security, we still need services or professionals that are skilled enough to understand these alerts that Justin was talking about, right? So for someone, and I heard of multiple attacks in the past on public cloud, many of the issues that we have there is that the amount of alerts that they have to handle, even in a SOC, it's huge, right? How can you drill down into 2,000 alerts per hour to understand what is exactly that is going on, right? So it's impossible. You need to rely on services that are specialized and purpose-built to narrow down this amount of alerts and tackle the important ones that should be addressed as an incident.
Yeah, we touched on one of the. Sorry. Go on, Taylor.
Thanks. Yeah, I think that's one of the messaging we use a lot is for shift left security, that the amount of alerts that the SOC is facing now is multiples of what it was before. And so it just makes shift left security, fixing the low hanging fruit earlier, all the more important, so that the security team isn't just closing port 22 across the board. They can actually go and do their threat hunting, the more valuable things that they should be doing, and worry less about the low hanging fruit that should be solvable by the developers themselves.
Yep.
Yeah, and we're touching on a real problem here, which is we need so much more SecOps, right? Because we are in dire needs of SecOps. There's an industry shortage that is tremendous. That's never been seen before. And we have tons of developers. We have a lot of DevOps, but we don't have enough SecOps. Meaning you can put in production everything you want pretty much as fast as you want. The problem is you cannot possibly control as much as you would want. So this is where we need tooling. This is where we need automations. This is where we need intelligence. This is not where we need to be very flexible. And the next, iteration of security should be to render those people far more efficient than they are. And it's not because they're not working. It's because they're flooded.
And the final thing I'd add to this, I use this analogy, right? You're building ships, and what we used to doing is building a ship, sending it to water, and then when it has some of the integrity failures in it, we patch it, right? We put a patch on the ship. And now what's happening is, with cloud security and some of the innovation that's come through, we're building so many more ships, and we're putting them out to water so much more quickly in an automated way. And there's not enough people to go and patch the holes for these ships. They'll take on too much water and they'll come down. So what we've done and what's happening in security is to try and make and build ships that have as little integrity failures as possible, so that they will require less and less need for security operations and patching when they're out at water. Now, of course, this vulnerability is disclosed all the time. So even if you think you've got the perfect ship out to water at build, something's going to happen later down the line that proves you otherwise, but there just simply is not enough people, to Philippe's point around security operations, to accept ships that are not built with the thought in mind. We need to reduce any integrity failures which may lead this ship to bringing on water.
Mitch, you mentioned something that I think is really important, that I want to make a separation between cloud native and cloud. This is something you can do on-prem. This is something you can do on-prem, but immutable infrastructure and immutable containers. So kind of that new paradigm of containers should do their one thing well. The Unix philosophy means that we can have lighter weight agents. We can have them make sure that they're only that any change to the container is automatically bad. And also wiping out persistent threats just means updating is wiping out that old virtual machine and spinning up a new one, rather than the old method of patching something in place, which is a whole new paradigm that, you know, is obviously something you can do on-prem. But I think it's kind of a nice, immutable infrastructure was designed more for operations, but it has a nice side benefit for security.
Yeah, that's why I think DevOps are actually the reinforcement that SecOps need. You know, just to bounce on what Taylor said, it's just, if you have the flexibility of redeploying anything that is dangerous instantly with a new version, then your SecOps desk is in charge of saying, this is dangerous, kill it. And the guys in the DevOps team can do the magic instantly within seconds, which makes a whole world of difference.
Yeah, it's interesting. Paul posted out there a comment about cloud security means we have to rethink security because the threats are changing as well, right? So you're pointing out about containers and the speed and the dynamic nature of just how we can change our environment, the applications in smaller bytes, containers and orchestration. It seems that our software architectures are also more porous, so if I can use that word, with API-centric apps that are built on their own APIs rather than, with microservices, as opposed to APIs are how you get from the outside in. That seemed those software architectures, and you had a good point, Taylor. You can do that in a private data center. You don't have to do that in the cloud, but it's born in the cloud, so we think of it as cloud native. How does that change how we think about security? Do security professionals now suddenly have to become software architecture experts in containers to secure this stuff, or how do we think about that? Anybody want to jump in? Long question, so you can answer any part of it you want. I give you a lot of flexibility there.
Yeah, I think to your point, the last point you raised, Mitch, which is, do these developers now that thought they were joining company X, Y, and Z to build cool apps and code, do they have to now, as part of that scope, become security professionals too? Which wasn't necessarily what they saw advertised when they came through the door. Yes and no, right? I think developers always need to be concerned as part of developing cool code and a great application for an enterprise company or any organization for that matter, making sure that it stands up when it goes out there into the wild, and security is a big part of that, because that can bring it down. It can impact the customer's experience that service is intended for. So always that should be par for course as part of the developer's thinking. But the reality is, it's not what drives them, right? We know it's not what drives them, which is why you often get this friction between security and development. That we all, I think, are very aware of. And one of the things that I think where security is pushing is, how do you, as part of what the developer needs to do early in the development cycle as they move through an automated CI/CD, provide security guardrails so that they don't necessarily need to think. There's automated checks and balances in play that allow them to do their job in a way that they don't kind of burn cycles unnecessarily, and still ship really secure code. A good example of that is the different security tests that you may have as part of a CI build process. If I merge my code and then commit for testing, and I can see as part of a security scan that there is risk involved as part of that check, should I promote it to the next stage, or should I raise that to the developer really quickly so that they can make adjustments To that may be updating some third-party components. It may be changing some of the SAMTAC or input validation, things like that in the code. But they're things that can happen fairly quickly and at each stage, as opposed to building the code, putting it into a staging or even a production environment at worst, and then discovering you've got all these security flaws, and then basically rubbishing the whole thing and kicking it back to a bunch of different people that contribute to the application, which is very painful for a development organization and really not acceptable anymore.
Yep.
In the past, I used to do pen testing, and one of the worst we had is we breached a company in less than 7 minutes, a website actually. So the developer was actually found a superb way of making an identification login password on the website. He was downloading the password on the client side and checking if it was a proper password. Brilliant, right? So that stuff would have probably gone through a lot of automated checks. And nevertheless, the company would have been breached. So I'd say they need to be made responsible. They need to be trained. They need to learn their trade. They cannot possibly use the resources on the infrastructure just saying, oh, I'm here to code, I'm here to have fun. No, you have a responsibility in the end.
Yeah, I was going to say, I think that we should never expect that a developer is going to become a security professional, and on the other side as well, that a security professional is going to think as a developer, right? That's why we have the middle ground of DevSecOps, right? So it's really important to also understand here that while you have a lot of tools and controls and mechanisms to be able to ensure, let's say, vulnerability scans on the build process, those vulnerability scans or checks are performed based on known vulnerabilities, right? Even though we think that our infrastructure is going to be as immutable as possible, threats, especially zero-day threats, are not immutable by any means, right? So you always should expect to have new ways in which your applications, services, and microservices can be exploited, and you should keep that in mind. So that's why I think we talk a lot about vulnerability scanning through the CI/CD pipeline, enhancing this in a way to ensure pre-runtime protection, and it's essential. But at the same time, you should be thinking really seriously about runtime protection as well, and visibility throughout that stage as well. It's not just antivirus. It's not just basic definitions that you can use to issue detections or neutralize malware, because it might be an APT, as Curtis said, and how can you tackle that with an antivirus?
I would say, though, just to counter that most attacks are still resulting as a consequence of known vulnerabilities because it's low-hanging fruit, right? You've got a vulnerability disclosure, which in some sense is a roadmap for what the attacker then needs to do to exploit a system. Now there's a vulnerability, and you can, I think Philip made this point earlier, attackers have lots of automation at their disposal too. It's not just developers developing the code. So once you've got a list of these newer vulnerabilities, you can automate checking to see if the target organizations that you want to attack have these vulnerabilities and execute the attack. I agree with you, Yasser, in that, if you are determined to exploit someone, then yes, 0 days, you can put a lot of research into creating new types of attack techniques to exploit anyone. I think anyone can be pwned with enough effort, but the low-hanging fruit is the existing vulnerabilities, and most attacks still result from those. Some of the big exploits that we know that have made headlines, I won't mention any names, known vulnerabilities. So I think if you can at least build that into the process of development and making sure that you, one, reduce them as much as is possible from your development cycle, and two, validate which ones are the most important, because there are thousands of vulnerabilities that your team may need to handle, and getting to the ones that are actually exploitable, I think, is going to be key from a resource management point of view. Then you're in good stead. You're always going to need to fear the 0 days.
It's interesting you mentioned also the environment that we're operating in. One of the hot topics now is observability from a security standpoint, not just understanding operationally what the app is doing and what what the alerts and errors and things that we're seeing happen. What it makes me think of, let me propose a wild question. You can tell me if this is a reasonable idea or crazy. I think we need a DevOps pipeline for security, not just shifting left security into the software development process, but our tools, our configurations, our environment has to also be dynamic so security can react just as quickly as a container can be updated. I may need to change a configuration like we do with vulnerability rules or something like that already today. Is that a wacky idea, or you think maybe there's something to that?
Sounds
I
a
won't
lot
get
like
offended.
policy as code.
Policy as code, yeah.
Yeah, send your policies just like you send your code for applications through a pipeline. Make sure they're vetted, make sure they're tested, make sure they run in all the environments that your tools are running in, and version control them so they can actually be collaborated around. I think it absolutely makes sense. And then you can move a lot faster. Then updating a policy is just as simple as making some change and doing an apply, and it'll make that immutable change on your behalf.
But seeing this on a CI/CD standpoint is complicated because you will always need human in the loop to check for stupidity. You know, the example of like booking a flight ticket, right? I get to choose my flight place, the place in the plane, right? I want 2A, for example, right? But did someone check that I paid my ticket first? Or can I directly jump to the last stage and not pay and choose my place? It's been seen in the past. I saw that in Black Hat, 10 years ago. And this is a logic failure. It's not a technical failure. This is why I think there will always be human in the loop, at least to oversee things a bit.
Sure, and that's just like in application code, no one's gone full DevOps where no human is involved. Usually, once you check it into a repo, open up a pull request, there's usually at least a couple reviewers. So there's all the automated checks that go through unit testing, integration testing, et cetera. And then there's usually like 2 human reviewers that have to sign off before it goes through. I think same can be true of policies. You go through those automated tests, those should be the first gate. And as long as you get through those, then you get to the human reviews.
That'd be great. That is a complete pipe for me.
Yeah, I just get on to say I'd agree. You need to have some. Actually, one interesting thing is, look, the technology is there. The technology is there from a security standpoint to automate all of this. So to your point, Mitch, could we get to a point where there's a security pipeline and security reacts on the trigger of there being an attack that's been identified? Absolutely. But there's 2 things that come into play there. Who writes the policy, right, for what happens? And is that policy developed right? Is it going to have significant implications if that policy is written wrongly? So that's one thing that is a big consideration. But 2, the other one is the efficacy. We've got to assume if you're going to automate security policy in such a way that efficacy has got to be really high. If there's false positives in there and you're reacting to those false positives, that's also going to have a detrimental impact. And that's where I see customers rightly pushing back on that idea of automating security totally. So there's 2 things that need to happen. You need to have policies that absolutely make sense, tried and tested, and you need to have very high efficacy to move the needle in terms of automating as much as possible. But I agree, at where we're at now, we're always going to need some manual review steps to take into account the nuance of change in the environment and to check that policy applies correctly.
Justin, I know you've got a thought on this.
Well, I would say, so I think you introduced it as observability, Mitch, and I'll just say, to me, the hierarchy of maintaining availability and maintaining security both roll up to observability. So if I'm thinking as a developer would, what would I like to know given an event that I'm trying to diagnose in production? What would I like to know around that event? That's a very similar thought process to if I receive the alert in the SOC. And in fact, blending together the idea of on-call and alert interpretation is kind of another way to test that you have sufficiency for both, right? So I would just say, is there enough context? Can I trace? Okay, because the reason you want to trace a request is, again, the same for a functional diagnostic as it is for a security diagnostic. So that's what I would say, taking that observability umbrella and making sure that you're increasingly over time trying to roll security topics into it. Another way, incidentally, just that we shift left the security mindset is in our hackathons. One thing that just our regular sort of day-to-day development teams will do is adopt red team for the duration of a hackathon. So actually, self-attacking in those moments is really fun, and it can show you, gosh, I wish it can show you. I wish I could have logged one more bit of information or logged one assertion that I would log at runtime. Like, this should never happen. I'm going to log that so that we get an alert next time, and then I'm going to log it with enough context so that we can begin to see, an early indicator of someone that's probing a perimeter.
I was going to say it is also important here to think a little bit out of the box, right? So I've seen many attacks that I kept track of very recently where the biggest threat has been an insider, right? And nobody thought of it, right? Nobody thought that a developer could put something in Docker Hub to orchestrate an attack via supply chain using container images, right? So that's something that is really important to consider, right? That the same way we consider that the weakest link in the chain in security is the human, probably the top threat that we might consider as well is humans.
Still, one of our top security incident causes is configuration, right? Now, some of that's automated, some's not. Go ahead, Philippe.
Maybe one last thing on this, the tools need to adapt as well. We have static code analysis tool and stuff like that are not so dumb, but the thing is they are not really API driven. You need to pull your code into a complex interface and, start to trace in all. I haven't seen that many products that would do it on the fly or be addressable through API and make it a good job at it or a decent job at it to actually alleviate most of the dumb stuff.
There's a related concept around any sort of AI-driven thresholds, where explicitly signaling, I intend for something to change. please readapt as of this change event. I noticed that we have to do a bunch of those sort of signals manually.
This may be an area we can pick up from what software the world has done. I'm thinking about reInvent. The conference just happened. The top ISV partner of the year was a observability company. So there's a lot we may be able to benefit from there. Sorry, my my music is starting here. Talk about multi-cloud, Yasser. How does that affect us?
Yeah, well, it's really important to keep in mind that all of these modern services that we get through cloud providers are basically hosted in hybrid or heterogeneous type of environments. I believe that we all talk about the fact that while we use multiple services in the public cloud, we still see on the enterprise side big organizations hosting their workloads also in their own data centers or co-locations. So you need to have a solution that is optimized enough to address, I would say, three main challenges that any organization can face. The first one is compatibility. So being able to cover as much as you can, anywhere from workloads or VMs to instances and also to containers, and at the same time have a single pane of glass or something simple enough where you can see pretty much all your workloads and you can manage them from that specific point of management. I see there's a lot of point solutions, and it's interesting that you mentioned that one of the companies that was the product of the year on the ISV side was an observability one. We see a lot of companies that they provide really great value when it comes to observability, but there's this much that they can do when it comes to remediation, right, or response. And the other point of it is visibility, right? So how can you see not only at the level of that workload, but also at the level of the organization, how that attack is being orchestrated? Because for the most part, with the point solution, at least what I've seen up to date, you can see exactly what happened to a container or in a cluster. But after that, you're pretty much blind because that's all you're getting from, I don't know, the logs you can read from CloudWatch, right? But how can you see beyond that? How can you put all these pieces together to have an organizational level understanding of how that attack was orchestrated, which entry points they use in your network, and how you can tackle that.
What about remediation in the cloud? Is it faster, easier because it's dynamic? Is there any new challenges with that? Something we have to think about differently?
It all depends on the complexity of your environment, right? So if we're talking about just following best practices or CIS benchmarks, right, for AWS, for Azure, for Google Cloud, you can definitely use playbooks to automate all of these, right, and automate remediation. But if it comes to, let's say, more customizable applications, then it might increase the complexity of remediation. In that case, probably a playbook won't be useful anymore.
I'm gonna say your remediation speed and efficacy is a function of team. I think it's training and understanding. How much do you understand? How much do you drill? How much do you practice? So if you are doing all the time, then you're going to be fast and good at doing it. And that's another one where, in fact, like just because the complexity has increased, because the flexibility has increased, it actually increases the burden of practice. So very regular drills, very regular practice for everything all the time.
I love Taylor's approach, saying, with the DevOps approach, we can just crash the machine and restart a new version updated of whatever Terraform image we have. That's something we couldn't do in the past, actually. So if we have to kill a cube or kill a VM and restart it with another version, it's easier than it ever was before.
Really good point.
I agree. Resource management is Resource management is a lot easier than it used to be. And because services of the past, monolithic, services of the future, as a result of containerization, exactly, right? So not only can you can be a lot more targeted about what part of the service you are, bringing back to a last known good. For example, if it's under attack, you don't have to bring a whole service down. You can bring a part of the service that is being that is not meeting the health check, maybe, right? Like Kubernetes, for example, they've got kube control. It's very a standard DevOps practice when a container as part of a cluster has an issue. You can identify that issue and then spin up a new container as part of the last known good image to then present back without any downtime whatsoever. Security, you can use the same practice. If that part of that service is under attack, it can be considered ill health, and you can basically bring up another container completely orchestrated without any downtime. That would have been very hard to do in yesteryear.
In the world of pizza boxes, right? Appliances. The old way of thinking about it. It's certainly different. I mean, we can really spin up an environment to test it. We can cordon off a part of the containers of the apps, apply a new policy to it, see if that solves the problem before we roll it out everywhere else, right? It's not a binary decision anymore. We have a lot more options, which, to your point, Justin, too, is it's great to have options, but if you know how to use them and you can't do it in the moment, it's a lot easier to hit that golf shot you've hit 100 times than it is the first shot. First time, you're lucky if you kind of get it on the green, to use that as an analogy. Philippe, one of the things we were talking earlier about is things like frameworks for security that might apply in the cloud. I think open source is something of particular interest to you. Any thoughts, or where can we go? So we're just kind of making it up ourselves, right? The great thing is security is a very sharing community. We also like to build on some frameworks like NIST and other things, or open source, SNORT, going back to intrusion detection. Any thoughts on the role open source or other frameworks might play in helping us?
Yeah, as we said before, we need more people into the industry, right? So it starts with this already. We need normalization. That's why the frameworks are good, because normalization leads to education, and education leads to more people more aware of the situation and better able to answer the problem. Like Justin said, practice, train, and it will become natural. But we all need to speak the same language here. So when you try to identify a component you need, everybody has to put the same word on it. And if you are under an attack of whatever sort, everybody has to speak the same language. Open source in this is great because it's free most of the time, not all the time, but most of the time it's free. So you already get a first line of defense for free. So that's really a great add-on. On top of that, you can look into the code, so there's no shenanigans, there's no other supply chain attack in the making. So to name a few, yeah, there are a lot of open source kudos I'd like to send. Obviously, people like KeePass, for password wallet, have a password wallet, people, please. Things like OSSEC, NISP, OpenCTI, Wazoo, Suricata, OpenSense, all of those people are doing extremely good job. And we at CrowdSec are also trying to help. So, and as for the alliances, there is obviously, like you said, CNCT, Cyber Threat Alliance. It's cool as well. It's a really good project where people share their CTI and IOCs for free for the greatest number to be able to defend themselves. Cloud Security Alliance, ICSPA, Digital Freedom Rights Association all over the world. They are all great resources for you to learn, guys. So don't hesitate to leverage them. And as for the resources, there are so many free things of quality you can find online. It's crazy, like podcasts, YouTube channels. You can read on Reddit and NetSec. There are a lot of people that are sharing experiences, not talking about GitHub, obviously. And for the frameworks, I would also note MITR, sorry for my accent, and attack, MITR and attack, OWASP, Yara, things like this leads to a consensus in how we name things and how we remediate them and how we discuss about them, which is already important in the first place.
Yeah, and a lot of what we talk about is using frameworks as kind of your starting point. There's no perfect framework for every single company, but there are a lot of very valuable frameworks. We align pretty heavily to CIS and a lot of the industry benchmarks like HIPAA and PCI. And they're just really good starting points. So if you're new to Kubernetes, look at the CIS Kubernetes benchmark, really align your security practices there, and then iterate and customize to your need. I just think they're fantastic resources to get started.
Cloud Security Alliance is another great organization, has great materials, I think a certification, if I recall right. Well, let's do this. We're approaching, getting close to the end of our time. Let's close with this thought, this question. Part of paying it forward in our roles as security professionals and developing ourselves is how we continue to develop people that are coming into security. We need more people. Well, how do we make sure they're equipped and competent and skilled and ready to tackle the current and the next challenge? Is the approach we're taking now, taking a SANS course, doing something and, sandbox training, certifications that we have today, are those the approaches we still need going forward, or do we have some gaps we need to find ways to fill? Curtis, do you want to jump in on that?
Training is definitely a good thing, right? For example, Justin mentioned, the kind of red team kind of events that happen. If you're a developer, for example, developing a service, bring them into that activity, or at least make them aware of that activity, the results that came through, so that they can learn from it too, right? There should not be a silo of information as it comes to these activities, because that doesn't necessarily serve sustainable learning for the people contributing to the issues in the first place. So things like that, I think, are really useful, and they're driven kind of internally. You do have external bodies that will come in and do that as well, of course, pen testing, things like that. So take advantage of things like that where you can. But I think organizationally, as a continuous process, is bringing the whole maturity around DevSecOps as a practice. I think that can help, right? Because it's bringing security as a first-class citizen into the process of development and operations, right? So the contribution to any risk, and then the operation is to kind of remediate against the risk and making security a part of that. So teams and the people that are doing the development are aware of the issues, right? They can change their practices and doing them little and often, right? They shouldn't be at the end of the development cycle. It should be at each step of the development cycle, at each review stage, as we were talking about, right? When you're having those reviews, they're great opportunities for learning moments for these developers. But in the end, what's really useful is what a lot of engineering teams need to do anyway is when they see security issues come back to them, they need to validate if the the security issue coming back to them. Is it a false positive or not? Is it really an issue that they need to deal with? Automating that process, removing the burden, reducing the load for those teams is really important, because there's no shortage of security issues that will be reported to these teams. How do you help them get some sort of instant gratification in understanding what is a real exploitable threat, so that they can prioritize their resources and then put those resources to bear in resolving those issues? Because I think a lot of teams at this point, if they get too much of a load of security issues coming to them, the learning moment is, I'm just overwhelmed. I'll just dig my head in the sand, and it's just too much for me to do anything about. So making, the security tooling can really help there in validating where the risk is. Things like code provenance, certifying trust between, the open source package that you pulled from a repo. I think to Yassir's point, is that a risky repo? Does that have a risky reputation, that package? And then having kind of a chain of trust going through your whole CI/CD development process, all the way through to you pushing that code out to the cloud. And we've seen the software bill of materials has been a big talking point recently with, I think, the directive from the Biden administration around government agencies needing to work with organizations that can provide a software bill of materials. Understanding the componentry, right, at a deep level, the componentry that makes up your build and the risk associated to that componentry is really important as well, because the reality is a lot of what's being developed now, nearly 70%, in some cases more of it, are third-party packages that are just being pulled in. So understanding the risk associated to those packages and how that can impact your service, and using that as a teaching moment as well, is really important. So I think it just really needs to be brought into the overall process of development, rather than having, just a session here and a course there. It really needs to be completely ingrained.
Mitch, I've got a response to. I think you asked, how are we onboarding folks into becoming security professionals? So I'll just say, if I have in mind that I want to be a security pro in 2023, I would advocate maybe a non-conventional path, but I think this is a productive path that echoes what Curtis suggested. Use all of 2022 to volunteer to some organization's CI/CD team and be called an intern, call it the most junior, call it I'm willing to do anything, but just be on CI/CD the whole year and learn the nouns and the verbs and the constituents of the application, and so that traceability, the provenance of code, just learn all that, and then back your way into production security from there, because you will have filled your mind with how the application is constructed in a development environment, and that's the mental model and the map that's going to be necessary to have intuitions once it goes to production. And everybody's always looking for more help in maintaining the CI/CD tooling.
Love that idea. Well, you'll know how it works for sure, right? Great. Others, jump in. Last minute thoughts.
Yeah, I had one thing in mind. I published it into the chat. It's about the company that stopped to underinvest as well, because it's if we have more people, it's going to help as well. And we have an extremely good example here in Europe, which is called the Gdpr Framework, right? So it's about data leak, and when you leak data from people, you are held accountable for that, right? And it's not like a slap on your wrist. It's like a meaningful part of your, it's like 2 to 3% of your turnover as a fine. So all of a sudden, everybody invested it right away. Like, the budget got unlimited one day to another. And that's a great movement somehow. The law has to also move in this direction to make people, and companies mainly, accountable for what they do, and help the security team to be, and the DevOps team to be properly tooling, manned, and trained.
Well, I'm going to have to pull the Ethernet cable out of the RJ45 port on this webinar and wrap things up so we can end it at the top of the hour. And I'm sorry, not everybody got to comment on that. I do want to thank our fantastic panel. We also want to give away our gift cards. Our 4 winners were Tim D, Tommy S, Abhinav K, and Julie G. So the folks here at TechStrong Learning will get a hold of you to get a hold of those gift cards. Just time to pay for some gifts and some buying for the season. So also just a reminder, we are sending out an email with a link to the recording for this. Please share it with your friends and let us know, what you think, how this webinar went. So I want to thank our illustrative panel. I really enjoyed talking with you all. It's a great group. Beginning with Curtis Baker, he's the VP Product Strategy with Resilient, and Yasser Fuentes, who's Technical Product Manager, Cloud Workload Security with Bitdefender. Taylor Smith, Senior Product Marketing Manager with Bridge Crew by Prisma Cloud. Philippe Humot, who is CEO and co-founder of CrowdSec. And last but definitely not least, Justin McCartney, who's CTO and co-founder of StrongDM. Thank you for being with us today. And thank you, audience, for participating with us in chat. Hope you all have a great day, a safe day. Be careful out there.
Thank you.
Thanks. Everyone.